A car speeds up with acceleration 2 meters per second squared from rest for 5 seconds. The driver then applies the brakes and the car stops in another 2 seconds. What is the total displacement of the car? So first we need to figure out the displacement of the car while it is accelerating. So we can just use this equation here. That its displacement is equal to, we don't have an initial velocity, the initial velocity is 0, to 1/2 times the acceleration of 2 meters per second squared times the time interval of 5 seconds squared. If you simplify this, this becomes 25 meters, and that's the first part. Now we need to figure out the displacement of the car when it's braking. So first we should figure out the acceleration of the brake. To do that, we first need to find out the initial velocity before it starts braking. So we know that the final velocity is equal to the initial velocity plus the acceleration times time. The initial velocity is 0, acceleration is 2 meters per second squared, time interval is 5 seconds, which equals 10 meters per second. Now, when it's braking, it's going from 10 meters per second to 0 meters per second in 2 seconds. So it's just minus 10 over 2, which is equal to minus 5 meters per second squared. Now we just plug this into this equation again, so that the change in x is the initial velocity times the time meters per second for 2 seconds, plus, this is really a minus since the acceleration is negative, minus 1/2 of 5 meters per second squared, and times the time interval, so it's 2 squared. And now if you simplify this, this becomes 10 meters. And so the displacement, the total displacement, is simply just these two changes, these two displacements added together. So the first displacement plus the displacement during the brake, which is just 25 plus 10, which is 35 meters. And that is the displacement of the car in this problem.